Hello, everyone, and thank you for joining our webinar today. My name is Clayton Ritchie, and I'm a program manager here at the University of Maryland, Robert H. Smith School of Business, Office of Executive Education. Our topic today is to chat GPT or not to chat GPT. We're going to have a discussion about generative AI, what it means for us as individuals and as members of the business community. And I'd like to introduce to you our speakers for today. We have Professor Suresh Acharya, who is a professor of practice here at the Smith School. He's also the academic director of the MS in Business Analytics. And you can see on the screen here his areas of interest and his contact information if you'd like to reach out to him. We also have Professor Kunpeng, or KZ Zhang. He's the Associate Professor of Information Systems, an emerging fellow in AI and business research. And you can also see his areas of interest and contact information up here on the screen. I've met both of these gentlemen, and I can assure you they are 100% real organic intelligences and not artificial intelligences, and we're very lucky to have them with us today. Now, what you can see here on your screen looks like someone writing an email in Gmail. And as they're writing that email, you can see some gray text appears at the end of their sentence. They haven't even finished typing their sentence and already some gray text has appeared there. What's going on here? Well, any Gmail user, you might have already seen this feature. It's got some predictive text that shows up when you can just press tab to finish the sentence. But the point of bringing this up is to show you that AI is something that's here with us right now. Any Gmail user, you've probably seen this already, and you might have thought, oh, this is something that's coming in the future, it will affect us all, but we also want to point out that it's here with us today in the programs we're using every day. Now, without further ado, I'd like to hand it over to Professor Zhang, who will tell us a little bit about generative AIs and LLMs.
Thank you, Clayton. Hello, everyone. So before discussing what is the generative AI with large language models and how it works, so I would like to take one step back talking about AI technology landscape. So the AI is a collection of tools consisting of many techniques. So basically it covers the supervised learning. The idea of supervised learning is to label things. And then generative AI, we're going to see a lot of examples in this webinar. And then other technologies such as unsupervised learning to learn the pattern encoded in data, as well as reinforcement learning to learn the optimal strategy by taking actions while maximizing the overall cumulative reward. So today we're going to focus on the supervised learning and the generative AI specifically. So in general, what is the supervised learning? It is part of the machine learning. So the machine learning is looking for a function. That function could be a simple function like a linear regression, can also be a very complicated function that does not have any analytical forms realized by deep neural networks. So it usually has the input, and then we take the input to the function, we get the output, and then output in the supervised machine learning usually are labels. Here are several examples. Let's say in the email spam filtering application, so the input is going to be raw text emails, and then the output will be the binary, either spam or not spam. And then in an online advertising application, so the input could be the ads itself, could be the text-based ad, or could be image-based ad, could be video-based ad, as well as the user information. And then the output is whether the user will more likely to click that ad or not. So in the brand monitoring, so we have lots of the reviews and comments about products in online platforms. And then we want to forecast or predict the sentiment of each individual comment or reviews, whether this is positive or this is negative. In the healthcare domain, so we have the electronic health records in a text format, and then we can leverage supervised learning to predict the readmission rate in the next a certain period. For example, one month or 3 months. And then in a finance domain, we also develop many supervised machine learning models to take the financial report in a text format as the input, and then predict whether there is the high risk or low risk for investment in the next certain time period. So I'll give you a concrete example in the supervised machine learning area to illustrate the general procedure or the process of machine learning. So the first step is to collect. Since this is the supervised, we need some human supervision. So we're going to collect the label data. So this is the example of product review sentiment monitoring. So let's say I get the first review from an online platform, and then I manually label it, right? Oh, this is positive. And then I'll get the second review, oh, this is negative. And then I'll get the third one, this is positive as well. It really depends on your application. Sometimes you may need hundreds of those X and Y pairs. Sometimes you may need thousands of XY pairs. But that's the first step. That's what we call, we're going to get the label data. Once we have the label data, we need to train and validate the AI model on those data. And then once we finish training and validating, we are satisfied with the performance of the model we trained, and then we're going to deploy. So we're going to run the model in our local environment for the certain applications. So now the question is, how can we train a model with the decent performance? There are two criteria we need to pay more attention. The first one is the amount of data. And then the second one is what kind of the model, what kind of the machine learning model we need to choose. There are two categories. One is the traditional machine learning, like a regression model, like a support vector machines, like those tree-based models, like those boosting models. And then the second big category is the current AI models. So they are neural network based. And then from this plot, you can see two observations. The first one is, with the same amount of data, the current AI models, especially the large-scale neural network-based models, can usually achieve better performance as compared to traditional machine learning or small neural network-based models, because those large models has powerful capability of capturing the complexity of the data. The second observation is, with the same model, if you have large amount of data, it's easy for us to obtain a better model because we have already seen many variations within the data, which makes the model, the prediction, the future unseen data well. So how can we deploy, let's say, develop a current AI model with the large scale of data? So that's pretty much in the past several decades, what we do about the machine learning. So in this decade, especially with the release and launch of ChatGPT at the end of 2022, we have seen many successful applications in various domains about those generative AI with large language models. So what is the generative AI with large language models? So it is basically, the fundamental idea is basically text generation process. So it's also fall into the category of supervised machine learning. So you're going to have X and Y. So the X is going to be the text. So it could be the raw text, could be the text with the instruction, could be text with the context. That's what we call prompt in the generative AI domain. So here's the example. Let's say I have a text. I say, I would like to have, this is the input, send it to the generative AI, like ChatGPT. And then we're going to get the Y, which is the output from the AI model. So here could be a cup of coffee without sugar, could be a bottle of wine. It can also be a piece of cheese. So it can also be dinner with friends. So those are the possible AI generated outputs. And then we wonder how it works. So as I said, the fundamental idea of generative AI is built by leveraging supervised learning to repeatedly predict the next word. That means you give me the inputs based on the model we have already built, and then we're going to predict the most probable next word. So let's say here, first I see the input, I would like to have a, and then the most possible word could be bottle. And then once I predict the next word bottle, I incorporate it as the input, and then I'll predict the next word. And then I'm going to repeatedly do this until I see the end of the sentence or end of the document. Then I'm done. So that's the generative, sort of the general idea of generative AI. On to Thresh.
Thank you, KZ, and thanks for explaining that, because that certainly now makes it very understandable for everyone around how Gmail, when you showed it earlier, was able to fill in the blanks. It was already generating the text. So thank you for that. Before we get into the applications of LLMs, based on the feedback that we got, our understanding was that some of you have already started to actively use ChatGPT, others have not yet. So what we thought we would do is, rather than just talk about it, let's go into a ChatGPT world and type in what KZ said around the prompt. So KZ, if you could, yes. So a lot of you may not know, I am an avid mountaineer. I have actually climbed Mount Everest with some buddies of mine. KZ, why don't you type who else climbed Mount Everest with Suresh? Let's just see what this thing says. And so that was the prompt. And so if you see what it is saying, in this case, I'm not sure which Suresh you're referring to. Of course, they're already, saying that they don't know me. But if you keep on going, there isn't a widely recognized figure by the name Suresh associated with Everest. And what that really means, folks, is, even though I told you, I actually have not climbed Mount Everest. And so ChatGPT was actually quite smart to very politely say that, you may have done this, but I have no information about that at all. So it is actually doing the right thing. It is actually telling us that, it's actually calling me out on my bluff. So for those of you who really thought that I climbed Mount Everest, in all honesty, I have not. So, here's an example where ChatGPT, frankly, is doing what we would like for it to do, right? So this is good. KZ, why don't we take a more nuanced example? I'm going to show a little bit of my age, of course. For those of us who watched Cheers back when we were a bit younger, and we loved all the characters. KZ, if you could type which episode of Cheers was entirely filmed outside the bar. Now, those of us who have watched that particular sitcom know that right from the beginning, they would actually show the bar. And so now what it's doing was that they're saying that the episode Thanksgiving Orphans, season 5, episode 9, while the storyline is set outside the bar. In fact, the very first line says that it's entirely done outside the bar, which it is not, right? So what is happening here is this phenomenon that some of you may have heard called hallucinating, which is it is collecting a lot of information. It feels like it has gotten to something that it feels confident about, and so that is why it is sharing this information with you. Some of the information is correct, but for it to boldly say that it was entirely filmed outside the bar is actually not correct. In fact, what is very, very fascinating and interesting about this particular example is every time I provide some kind of prompt like this about Cheers with the same kind of content, it gives me very different answers. And so that is what happens in ChatGPT. So if you have heard your friends or others say that you can't entirely rely on everything that it says, they're absolutely correct, because this is the phenomenon called hallucination. We wanted to show you this just to make this conversation real around what is ChatGPT, what can you do, when does it call you out, and when does it play along with you? Okay. Casey, back to you, please.
Thank you. So I'm going to use the next few minutes to talk about the applications of large language models. So in three major domains that I have been interacting with, the first one is in the finance. So the first use case in finance of large language models is going to be the easy sort of the case that's customer service. I'm sure everyone here has some experience with those customer service, especially in the banking domain. So whatever you typed or you asked, you may end up with the bad responses. So because of the bad technology, especially the traditional machine learning models, those bank services has deployed. So with the large language models, they are capable of understanding the human intention and then reply with better semantics. So if we can build a virtual assistant by those large language models, I'm sure we're going to end up with better customer service quality. And then the second application in the finance domain is we have lots of documents or reports from different sources for managers, for individual investors to look at, make their investing decisions. With the large language models, they can summarize, they can make inferences based on the text information they have seen for better or personalized recommendation for investment. And then obviously the third application in the finance domain is the report automation. You have lots of information, as I said, from different sources. How can we summarize them in a precise way for reporting? So large language models is very capable of doing that. In the healthcare domain, one of the projects we have been working on is the electronic health record understanding. So for some of the patients, they may have hundreds of pages of electronic records. So the physicians cannot read all for diagnosis decision. I mean, how can we leverage large language models to help the physicians to extract the key information within the clinical notes? For example, could be the drugs they have taken, how much, what doses they have uses, right? And then at what time they have taken those drugs. Is there any side effects? And then if we extract those key information, and then the physicians can make efficient or effective decisions. And then another application related to the EHR understanding is the document coding. As I said, patient clinical notes may have hundreds of pages. Some of the pages are related to demographics. Some of the pages are related to lab test results. Some of them are related to diagnose the results. Some of them may related to the side effects. Can we separate them or categorize them using large language models? Obviously, traditional machine learning models can do that, but the performance or the accuracy needs to be improved. The second application in the healthcare domain is what we call active health management. For those patients, for example, with the depressions, or those patients are not actively monitoring their health status. With the large language models powered virtual assistants, those assistants can help them actively monitor or interact with those patients to improve their health status. And then large language models is not only capable of processing text data, but also can take images as input. We have lots of medical images from the X-rays, from the CT scans. Can we leverage large language models to detect or diagnose the certain diseases? So the third area that I've been fortunately working on is education. So the large language models can be used for language learning, especially for those students who are learning second languages. Because the large language can help you translate, can help you complete whatever you have wrote, can help you to polish what you have wrote. It can not only help students, but also helps teachers or the instructors to create more diverse teaching materials. It can also incorporate what the students have already learned in the past to create more personalized teaching materials to help their learning. And then the third one is, so the large language models can evaluate what the students have already written and then provide the effective feedback. So in that sense, so student knows how to improve in a guide sort of the manner. And then back to Suresh again.
Casey, thank you for that. You know, we all learn something new every day. Thanks for walking us through those wonderful areas of applicability. And obviously, you're just scratching the surface. There are many more. But, you know, folks, those of you who are now kind of tired of watching some of these reruns because of the Hollywood writers' strike, as you know, one of the key issues in that particular issue is AI, and whether AI will actually replace the writers, right? And so with all the very optimistic, positive things that KZ mentioned, obviously, you know, AI and generative AI in particular certainly has its downsides as well. What we thought we would do is, you know, make it interactive. We'll have a poll question after this, but I want to show you a few images. What I'd like for you to do is to look at them carefully, and at the end we will ask you a question. So, Casey, the first image, please. Okay, please take a look. Image number 2, please. Good. Image number 3. Image number 4. Image number 5. Perfect. Thank you very much, KZ. And take a look, and the question, of course, is, of the 5, who is not real, who is fake? You know, so take a quick look, and I know Clayton's operating this. He will have a poll that will show up, and we would like for you to then guess who you think is fake.
All right, I just launched the poll, so everyone please vote on which image you think was fake. Or you can vote on more than one if you like. Okay, we're getting a lot of good responses here. I'll give you all a few more seconds to enter your responses here, and then we'll end the poll.
This is excellent participation, Clayton. This is great.
All right, thank you all for voting in the poll. We're going to end it now.
Okay, and so please take a note. It looks like image 5 got the most number of votes as being fake, followed by image number 2. And folks, we're obviously doing this for a reason. And the answer is all of them are actually fake. These people do not exist, and these are all AI generated, generative AI generated, and you may have heard of, just like ChatGPT. There is DALL-E. There, you know, other emerging areas as well. And so this just gives you the kind of, you know, understanding where this technology already is at. Clayton, if you could remove the poll now, I think everyone's seen it. Okay, or maybe I can do it. I get close. Okay, Casey. So with that background, then, and all of us have heard this, right? There are so many security and privacy concerns. data leakage, reverse engineering of training data, incorrect content generation, model bias, harmful content generation. What we just saw was nice and cute, but it can also be harmful. Regulatory incompatibility and deepfakes, all of these, right? But a good number of these are AI issues just in general. They get further magnified, they get exacerbated because of generative AI. We can generate a lot of content. Guess what? We can also generate a lot of incorrect content, right? We can generate content that is harmful. We can cook up stories that are absolutely not true, and generative AI will keep on helping us make it even more and more hateful, more and more violent. And then this notion of deepfake, it's absolutely not true, but they've made it to an extent. Whether we have seen, celebrities wearing certain clothes that they never really did, all of that is deepfake. Now, what is very, very interesting about this, and obviously, well, this list is partial, is I wanted to share with you the world that KZ and I live in. Folks, I cannot distinguish an essay that an applicant wrote versus an essay, an application essay that ChatGPT wrote. That is what we are dealing with. I give students assignments, read this case and, share your thoughts. I'm getting increasingly, amazingly great assessments of those cases. And increasingly, that amazing review is not human generated, it is AI generated. So we're living in a world where it is getting very hard. And now, of course, the question is, what do we do? What does academia do? Do we embrace this and then try to see how we can still make our students more creative, more thoughtful, or do we try to find ways to shield this away, which, as everyone knows, is getting increasingly difficult to do. So just wanted to share with you things that all of you know, but wanted to make this real as well. KZ, back to you.
Yeah, so we have seen many good things about the large language models, right? Developed by those platforms like OpenAI, Google, Microsoft, and right. We have also seen some security or privacy concerns about large language models. As the individuals or as the firms, how can we adopt those, or is there any optimal strategy that we can leverage to adopt those large language models? So I want to talk about, there are two stages about large language models when you deploy. The first one is called pre-training. Basically, it says we can train a model from scratch, like what OpenAI did, like what Microsoft did, like what Meta and Google did, right? Those ChatGPT or GPT-4, they leverage a massive amount of data, train their own model from scratch. So obviously, it is very costly. None of the individuals or some small firms can afford. Training once, the ChatGPT costs about $12 million US. So, and then these pre-trained models has the general knowledge to understand the languages in a broad sense. But when we deal with our specific context, let's say I'm in a healthcare domain, or I'm in a finance domain, those pre-trained general model may not be good. So we have to fine-tune the model and make the model shift towards our specific context or domain. That's what we call fine-tuning, the second stage, fine-tuning. And then most of the time, we don't have to train our model from scratch. We just leverage those existing pre-trained model and then fine-tune it to our specific domain. But the problem is, for those large language models, right, like ChatGPT or GPT-4, first, they don't release their models. So when you do your specific task, you're going to upload your data to their platforms where you don't have any control, especially for those sensitive or private data. You can't do that. The second one is those large language models are really huge. I mean, the inference takes time. So is there any alternatives? Fortunately, yes. So there are some open source large language models. We call them small large language models, as compared to the ChatGPT or GPT-4, like those models developed by Meta called Llama, or the Alpaca developed by Stanford, or the Falcon by TII. So they are open sourced. You can deploy them in your local environment where you have full control, right? And then the research has already demonstrated that with a small amount of data, you fine tune on those small large language models, you can achieve comparable performance with those existing large language models. And then it doesn't cost that much. Then the problem is, even for those small large language models, they're not that really small. So they have billions of parameters, still very large, right? How can we fine tune them using small amount of data on our personal laptop? Some researchers has already shown several techniques can be leveraged. That's what we call parameter efficient fine tuning. So I want to get into the details about those technology, but basically there are two. One is called the re-parameterization. The other one is called addictive. With those technology, we can fine tune those models and make those models shift towards our specific domain on our own personal laptop with only 1 or 2 GPUs. That can save you a lot of money. It can also address the security and privacy concerns you might have. So with that, we would like to have, we will be very happy to take any questions and then you might have.
All right, I'm going to monitor the Q&A over here, but while y'all are thinking about the questions that you want to ask Suresh and KZ, KZ, maybe you can tell us a little bit about the research that you're doing or the folks in your peer group that you're talking to about this. Is there anything that you're hearing or seeing that makes you think what the next big thing will be?
Sure, absolutely. So I just want to take one sort of the personal example, right? So recently I attended one of the largest AI conferences called KDD in Los Angeles, Long Beach, 1 month back. So within that conference, we see the application of those large language models in different domains. So in finance, in healthcare, and then in education, obviously. And then whenever there's a talk or the workshop related to large language model, you're going to see full house of audience. So I see that it's going to be a trend. And then obviously we have some sort of the concerns or the performance about the large language models. So there are a lot of rooms to improve. But I'm sure with the effort of those researchers and professionals, we're gonna tackle this. We're gonna mitigate those sort of the concerns. And then another thing I want to mention is, so the OpenAI will release their GPT-5. I'm sure they're going to have GPT-6 and GPT-7 with more data incorporated, with more advanced algorithms incorporated. You're going to see the language understanding and also becomes more intelligent.
Wow, that sounds really interesting. So thank you, KZ, for that perspective. And while you were talking, we did get a couple of questions coming in from our attendees, and I'd like to share the first one with you. It's a question related to those applications in the healthcare field that you mentioned. One of our attendees asked, if LLMs are prone to hallucinations, how can we use them for a serious application like medical health records? Can we be confident that the results that an LLM would give us or AI would give us in this healthcare context would be reliable?
Yeah. So Suresh, if you don't mind, let me first just chime in. Yeah. So there are several technologies involved in large language models that we haven't mentioned, right, behind the model. So one is called the human feedback in the loop. So how can we prevent this, or how can we mitigate those sort of the issues? One of them is we need to build another model along with those large language models to take the human feedback and then give the large language model some guidance of whether the output you generate from the current iteration is good or not, right? And then you can also fine tune, as I said, the second method, you can also fine tune your model and then make it more human aligned instead of random, or let the model generate. So that's just my response.
Yeah, Casey, great. And really building on what Casey said, I think there's a general inclination perhaps to know whether or not LLMs can work right away in every domain. And I think what Casey's really alluding to is we are just getting started. And so what needs to happen is further refinement. The way I see its applicability, much like what Casey just said, is it's probably a starting point. Don't take it for what it is right away. See what it's saying. And if you have sufficient doubts to kind of say, maybe that's not entirely correct, then obviously we want to train things further. We do want to start to get these large language models not to hallucinate, but right now they are prone to those, right? So, Clayton.
Well, thank you all for answering that first question. We've had a few more roll in, so if you don't mind, I'll just go on to the next one. One of our attendees asked, how much data does an LLM need for training? Is there a minimum amount of data where maybe some users would not be able to use this just because they don't have enough data?
Yeah, that's a great question. So for those pre-trained models, if we just use those pre-trained models, we don't need any data at all that we can run LLMs because they have already pre-trained for us. What we need to provide is just the task or the input, right? And then the second one is what we call the few shot learning. So if you don't provide anything, that's what we call zero shot. The second one is called few shot. You can provide some demonstrations and then give the model some guidelines. Hey, when you do the sentiment identification, here are several examples. And then let the model learn in that domain. And then the model can learn something and then to predict whatever sentiment it is for your input. And then if you want to pre-train, let's say train a large language model from scratch, and then if you want to obtain a model with good performance, obviously it needs a massive amount of data. Because think about that. So those large language models has billions of parameters, right? If you want to learn those models without overfitting, you need at least billions of tokens or billions of instances. When I say instances, the text document or sentences to make the model work.
All right, Suresh, did you want to add anything to that, or should we move on to the next question?
Let's actually move on to the next one. That was great, Casey.
Very good. Okay, the next question from our attendees is about traditional machine learning and overfitting. In traditional machine learning, overfitting is a concern, and is this a bigger concern when we use larger neural networks?
Very good
I'll
point.
let you take that. Yeah.
Yes, very good point. So the overfitting is one of the, I would say, major issues in machine learning in a broader sense, right? So there are several ways we can deal with the overfitting. The first one is what we call data augmentation. You increase the training the set to let the model see more variations. That's why for those large language models, they leverage billions of sort of the documents, right? And then the second technology in deep neural network to deal with overfitting, I'm sure the OpenAI has already leveraged it. That's what we call the dropout, to make the model a little bit less complex, right? So there are many technologies has been incorporated into the large language models to mitigate, to address those overfitting, right?
Yeah. And Casey, those techniques, those methods will only increase and evolve over time as well, right? So yeah, exactly.
All right, thank you for answering that question. I'm going to look at the next question from our attendees. They keep coming in, and I love to see it. Thank you all for your great questions that you're typing into the Q&A here. So the next question is about the regenerate option on ChatGPT. Is this used as part of the training model?
So
And I think the question is about, you know, that button that you see on the Chat GPT's prompt where you get to regenerate the answer if you want a different version.
Yeah. Thank you for that question. Suresh, if you don't mind, let me take first. Yeah, right. Yes. So the ChatGPT or GPT-4 was designed specifically for the situation where the conversation happened. Right? That's what we call conversational AI. So basically you provide the input. That's what we call prompt, and then the AI system reply with their output. So when the AI system does that, it does two things. The first one is what we call NLU. It's the natural language understanding. First, they're going to understand what is the intention, and then the second one is what we call NLG, natural language generation, and then they're going to generate the output. Right. So once, let's say, you send the input, the AI system understand and then output the response, and then you can continue interacting with the AI system with many rounds. And then the AI system learns what you have asked before, and then generating the corresponding responses. So basically, it can regenerate. And then another thing I want to mention is, as Suresh already mentioned, every time you send the same prompt, you might end up with the different responses, right? Because the AI system want to have one of the objective, obviously, is the diversity, right? The other one is the novelty or the precision. So they have already incorporated those. Like a human being, whenever you give me the same question, I may tackle that question in different angle, so give you different sort of output. But the fundamental idea or the fundamental answer could be the same.
perfect, KZ. And I think there might be kind of a subtle question there as well. Will ChatGPT take my prompt and potentially learn from that? And the answer is absolutely yes, right? So, Clayton, on to you.
Thank you all for answering that question. I'm going to look at the next one here. And I think a lot of our attendees were very interested in the latter part of the presentation, KZ, where you mentioned the other open source generative AI resources that they might be able to use. And this user, or this question asker, was also very interested. They said they can't use a chat bot on their corporate network when they're at work, and they want to know, is there a way that I could download a local model and host it locally, so I could alleviate some of the privacy concerns and the worries about data leaks that my company has? And can I do this, and will it still work, or is the model going to be compromised in some way since it's running on a local machine and not the full that doesn't have the full computing power behind it?
Yeah, that's a great point. So exactly. So you can download you don't have to download their trained model because you are worried about the data leakage, right? So you can just download their code. If you want, download their code. The first one, download their code and train using your own data. The second one is download their pre-trained model in your local environment and then fine tune it. So, and then you're going to have the full control, and then you're going to cut the internet so the data leakage will not exist. So there are two ways. One is train your model from scratch using your own data. The other one is fine tune those small large language models, open source models in your local environment. I'm sure, I mean, they are not that costly, and then you will not have those privacy and security concerns in a big manner. And
KZ, that is why you were kind of highlighting those smaller LLMs anyway, right? Look, here are some that you can bring in-house, basically, train it with your own additional data, and then keep on training it with your own data. And of course, you need to give your leadership the confidence that your data isn't going out there, exactly what KZ meant in terms of cutting off the internet.
Yeah, I just want to add one more point. Let's say even you don't want to cut your internet, right? So you still want to connect to outside of the world, it's fine. So you're going to build another module, what we call the safeguard. So let's say whenever you try to access the internet, better make sure you have a safeguard over there. You know what kind of the data will go out, what kind of data will come in. So, but the large language model can give you the output, but you're gonna check those output. right? So that's, you can build another model on top of the large language models. So that is completely doable.
I can tell this is very interesting to our attendees. I see a lot of questions coming in about this right now, and I want to bring one of them up. It just came in. What do you mean by downloading their code? You mean the code of the model? Tell us a little bit more about what you mean when you say that.
Yeah, so they have, let's say for the llama, and then for alpaca, and then the falcon, they all release their source code, how they build their model, how they train their model, and then how they validate the model, how they process their data, right? Basically, separate the document into sentences, separate sentences into words or tokens. So they have all the operations released to the public. You can download their code, and then with your own data, train from scratch. That's what I mean by downloading the code. Hopefully that makes sense.
Okay, thank you for answering that question. I feel like the next question could be a great topic for another discussion. It's about AI uses in marketing. Are marketers using AI to identify ideal target customers and help generate campaigns to reach those target audiences?
Clayton, I can take that, and the answer is exactly like you said. The answer, folks, is it possible then to identify a more precise, a more impactful customer segment that you want to present your product, your brand? And the answer is absolutely. And as Clayton has mentioned, we intend for this webinar series to be a series, and one of the, if not the next one, soon thereafter, we are planning to have one that addresses this specific topic in a lot more detail. So stay tuned, folks.
I just want to add one more point in terms to this question, right? So when we say AI or the generative AI, they are not necessary to be large language models, right? So they can be many other models, and then they can leverage those foundational or the key architecture like transformers. So we here in the Smith School, we have been working on a project, exactly the finding the target audience based on the social media data we have, right? So we can build an AI model in a broader sense, and then learn the user preference based on their historical activity, interacting with different kinds of brands on social media platform, what kind of the pictures they have been posting, right? What kind of the sort of the interactions with their friends, and then the social network information. We can put all this information together and then send it to the foundational model in AI transformers to learn the user preference, to learn, eventually we're going to find the target audience. Right? It's not just large language models, but can also be many other what we call AI models.
Yeah. Casey, thanks for clarifying that, right? Look, we don't need generative AI to do that. It might obviously do more, but those of us who remember Cambridge Analytica from an earlier election cycle, they really were able to synthesize and combine many different data sources, past voting records to, someone's job, to whatever they may have posted, to say, let me send a certain type of communication to that particular voter, because they had a good feel that that voter would actually respond or reciprocate or, have some kind of meaning to that targeted messaging. So absolutely.
It almost sounds like there are applications for this technology in so many ways that we haven't thought of. And any situation where a user was confronted with a lot of data, you could deploy a technology like this and it would give you insights into that data that would otherwise take a long time for a person to pull out. Is that about right?
Yeah, it depends on what kind of data it's available to you, right? If you have those users sort of the chatting data, their text data, I mean, obviously you can leverage a large language model to understand their characteristics, right? If you don't have those, you have their social network information, you can use AI-based network analysis, right? If you have the sort of the historical behavioral interactions with brands, you can use other AI models, right? It's not just necessarily large language models, right? Or the large language model is the general term. Even as we mentioned, large language model can process images, right? Can process videos. So it's not just the text. Yeah.
Okay, that wasn't a question. That was just my thought as we were going through it. But we do have some other questions coming in from our attendees, and we'll use all the time we have to answer these questions. So I do want to move on. I have another question about using one of those systems that you mentioned, those open source language models. Is this something that the everyday user can use, or do you need some background, some experience in order to be able to really use these open source language models to their fullest capabilities?
That's a great question. So yes and no. So so if you have some knowledge about machine learning or the coding, like Python-based coding skills, I'm sure it's easy for you to deploy that on your in your local environment. If let's say for most of us do not have any coding experience or background in machine learning, it's also not that difficult, I would say. So one of my students, he doesn't have any machine learning background. Recently, he figured out how to deploy the Llama in a local environment, but it's not a local. So he uses the Amazon AWS because we don't have a GPU right here in our office. So so they have you can easily find some instructions to tell you how you're gonna deploy those open source large language models, and then so here at the Smith School, we are also happy to help you if you want to do those. We can help you on that. Yeah.
Yeah, and some of these are evolving because we're just starting. Think about where we were at this time last year when the big ChatGPT splash had not even happened, right? Think about how much has changed since. So this notion of can this ever be plug and play, or can some of this be plug and play? I think this is where we'll eventually go, even if it requires a little bit of work now, right? And the one thing that I did want to also share is before this webinar today, I went back to Gartner, those of you who know Gartner, and look at their hype cycle to see what they had said back in 2021, for example, around what are the newer technologies that might be coming. And generative AI was certainly on the list, but there were 25 other technologies that they mentioned as well. So while we're all getting very excited about generative AI, not all of those 25 will eventually pan out. Some of them will, some of it won't. But there are other interesting areas of AI and advanced analytics that continue to evolve. So just wanted to put that out there. Clayton, back to you.
Thank you, Suresh. The next question that we received is about deepfakes. Can you tell us what is being done to combat deepfakes?
Casey, do you want to take that? Because this is a wonderful segue into our very next webinar. But let me just first say that, Casey, and then I'll pass it on to you.
Sure.
What we are hoping to do is one of our Smith School faculty, Professor Rama Prasad, this is her area. Disinformation, deepfake, how does it get started? How does one combat? What can really be done about it? Stay tuned for more details on this. But Casey, if you have a couple of quick thoughts on combating deepfakes, I'm sure our participant would love to learn that.
Yeah, I just want to say a few things. I'm not a sort of expert in deepfake, but from the algorithm perspective, it is a battle, right? So how those fake images generate that look real in the world, right? So because there's the algorithm called generative adversary network, so the algorithm itself battles to itself, I would say, right? So they have two components. One is try to generate an image that fake the the system. So they generate fake images to let the system couldn't, let's say, identify this as a fake image. So like those large language models, the text-based large language models, there are some models have been built to detect whether this is from large language model or this is from the real human being, right? So for the deepfake, there are some models, but it totally depends on the performance of the model. Some of the models are really good, some of the models are not good, and it also depends on the area, right? If it's, let's say, in the game area, whether this is the real image or the fake image, or in a celebrity area, whether this is the real or this is it depends on the area. So yeah.
And like Professor Suresh said, this is something we would like to cover in more detail in another webinar. So please do stay tuned if you're interested in this topic. We will be diving deep into it in another episode. But I'll move on to the next question. We may not be able to answer all the questions today. I see there are a few more that have come in. So let's keep in touch via email. If we don't get a chance to answer your question today, please email me. My email, it should be in the confirmation registration email that you got. Please reach out to me with a message if we didn't get to your email. And I'm just saying that because I can see some of your names on this, but some of your questions came in from anonymous users. So if you answer if you asked anonymously, I may not be able to, find you and follow up with you later. And that's fine. Let's just keep in touch and find a way to answer your questions, because I know that our professors would love to be able to address all the questions. I think we have time for, well, here, I'll do my quick thank you, and then we'll answer that last question. I want to thank everyone who stayed on to the end, everyone who's asked questions. Thank you so much for attending and interacting with us today. If you are interested in this topic and you'd like to learn more, Professor Acharya and some of the other colleagues here in the Smith School have created an online course, and it really dives deep into these topics. You can learn a lot more in this course, and I've shared a link in the chat so that everyone can see this link, see this website or the online course if they're interested. We'll also send out a link to a recording of this webinar via email. So give us a few days just to get that ready, and we'll send that email out to everyone who attended so you can watch the recording later. But with the few minutes that we do have, I want to see if we have time for one more question. And that question is about blockchain and AI. Are there any intersections in the world of blockchain and AI?
Suresh, maybe you can take that. I'm not an expert in that area at all. So blockchain, yeah.
So what I love about these questions, whether it's deepfake, whether it's targeted marketing, whether it's distributed ledger / blockchain in general and AI, folks, these are the upcoming topics. One of our faculty members, Professor Tej Anand, is squarely at the intersection of AI and blockchain. And he has already given a few webinars on it. So the short answer is there an intersection of blockchain and AI? And the answer is absolutely there is. Where a generative AI comes in with blockchain is an area that I'm not that familiar with, but I hope when we get to that particular series topic. And I'm so glad that you're asking this question, because it validates what we thought would be of interest to you, right? Are you going to be interested in this? And just the fact that you ask these questions validates that. So thank you for that. Well, the short answer is yes, but stay tuned when we have a more detailed session specifically on blockchain and AI, and especially the extension with generative AI.
Thank you, professors, for joining us today. Thank you, all of our attendees, for listening in and asking such great questions. We look forward to seeing you next time when we can address more of these topics in detail and field more of your questions. And if we didn't get a chance to answer your question today, I'm sorry, but please send me an email and we will follow up with you as best we can. Thank you again, everyone, for joining, and enjoy the rest of your day.
Bye-bye. Thank you.
Thank you.